Hello and welcome. I am Dr. Anil Joshi. Welcome you to my series Learn Radiology with Dr. Anil Joshi. I am Professor of Radiology and is well experienced since in teaching field. I am from 1996. I know the difficulties of students and particular this topic they find bit difficult. So today we are going to make it a simplified one. So let's get going with a radio physics, and today's topic is Bremsstrahlung, that is the type of radiation which is very important as far as image production is concerned. So let's get going to the topic. To start with are the disclaimers. Most of the material which I am going to use here is from our department. It is going on since many years. We are using it for every batch. Some of the illustrations are from net. However, we are confirmed that they are royalty free. Now, how to pronounce it is very important. It's a German word which means breaking off or breaking of radiation. It is the Bremsstrahlung radiation. This is a primary mechanism by which diagnostic X-rays are produced. The word literally means breaking radiation in Germany, and it refers to the way a high-speed electron shoots or slows down and breaks when it approaches the positively charged nucleus of a target atom like tungsten. So, since the process results in breaking, hence the name. The sudden deceleration causes the electron to lose its energy, and that energy is emitted as an X-ray photon. Photon is nothing but a pocket of energy. Because the amount of deceleration varies depending on how close the electron comes to the nucleus. As you know, closer the nucleus, larger is the energy. So, the amount of deceleration varies depending on how close the electron comes to the nucleus. The X-ray production have a range of energies resulting in a continuous spectrum. Now, in different lecture, we have made this concept also very clear. Now, what is Bremsstrahlung radiation? Major component of the diagnostic X-ray spectrum, especially at higher KVs. Let's take from 60 onwards. Produced when a high-speed electrons are suddenly decelerated near the nucleus of the tungsten atom. That is what we have seen. Now the word also we have seen, that is the Bremsstrahlung means breaking radiation. Now how it results in a continuous spectrum is because closer the electron displaced, higher will be energy liberation, and the peripheral one will have a lesser. Now how it is, we are going to see it with the help of diagram very soon. Now let's continue this mechanism. We are going step by step. The electron from filament hits the target atom. What forms the target is a tungsten. As it slows down, due to nuclear attraction, energy is lost. This lost kinetic energy is converted to a X-ray photon, because energy can never be created or lost. That is law of conservation. The closer it gets to the nucleus, the higher energy it emits. That is what we have seen. Now, what we are going to demonstrate you very shortly, that is the nucleus with electron path curving near it, then the arrow showing X-ray photon being released. This we are going to see very shortly once we complete our theoretical discussions. Now, what is the clinical relevance? Why I should know it? The Bremsstrahlung makes 90 to 95% of the diagnostic X-rays. Hence, they contribute major formation of image, since they are 90 to 95%. That is as far as standard tube between 50 to 150 are concerned. Certain tubes are different. We are going to discuss them in the topic of tubes, particularly mammography. The crucial for generation radiography, it is very crucial for generation because the diagnostic range is in between 50 to 150. Forget about 50 to 60 and forget about 110 onward. But in between 60 to 110, this is the most important diagnostic range of the X-rays as far as KVs are concerned for chest, abdomen and spine in an averagely built person. The high energy Bremsstrahlung is filtered out to reduce skin dose because they do not form images. Whatever are the low energy photons, what are the low energy X-rays, they are of no use, they are filtered out. Again, there are different lectures for that. Now what you will see in visuals, you will see a graph showing continuous X-ray energy spectrum with filtration cutoff. This we are going to see as once the theoretical discussion is over. Now what are the examination tips and what are the tips for the recent? Peak energy is equal to KVP selected, but most photons are less than 1/3 of the maximum energy. So there is a loss of energy in these. Where the loss of energy goes, it goes into the heat production. Now efficient X-ray production is less than 1%. The rest is become either heat or they become the non-useful photons. They have got low KV. So they are of no use for the diagnostic purpose. They just cause a fog. Now tungsten is used due to high atomic number, that is 74. It enhances Bremsstrahlung effect. So that it gives us better useful X-rays. Now there are two types of radiation. One thing is called Bremsstrahlung and other is called characteristic. What is the difference? Now let us see in tabular form. The first, as it says, is Bremsstrahlung and second is characteristic. Now type of spectrum, continuous versus discrete, depends on electron deceleration versus characteristic depend on the electron shell binding. Then energy range is wide up to maximum KVP. What we have seen is up to 150, which we use rarely, but up to 110 sure. Now specific to the element, characteristic radiation is produced. It is dominant at more than 70 kVs and minor at 70 to 100 kVs. So these are the ranges of it and these are the limitations of it. Now here we are seeing interactions, how it occurs. We are seeing a nucleus, we are seeing a K and L shell, and we are seeing a electron from the filament. How it comes? It comes straight, it hits the K shell and that results into a radiation because the energy that electron possesses is lost. The electron from when it comes from the cathode, it hits it and it gets suddenly decelerated and results into the X-ray production. Now moving electron from the filament. Now let's see in which step it goes. Moving electron from filament, the nucleus of the target atom. Then nucleus causes, it has got positive charge, it causes moving electron to change its speed and direction. The electron slows down, that is the deceleration, and it loses its kinetic energy in the form of a Bremsstrahlung X-ray. So that is how it is produced. Here also we are shown same process. We are continuing this, how it is called as breaking radiation. You have seen now because it is decelerated. A first path of electron is changed and it results into the X-ray radiation. Now small amount of energy is lost with interaction. Now there are a lot of things in which the energy is lost. There are a lot of things in which the X-rays are produced. We are going to see them in different topics in radiophysics. Now radiation energy, loss of moving electron depends upon the distance from the nucleus. Closer it has got higher energy. Then charge of a nucleus. Then Bremsstrahlung energy spectrum. 0 is a peak voltage applied to the tube. Most Bremsstrahlung photons have a low energy and they do not escape the tube. They are either filtered with there are different type of filters right from the X-ray production till it reaches our body, and in between there are different videos covered this topic. Now they can be easily filtered by tube filters or outside the tube, so that low energy will not cause a fog or it will not result into the distorted or bad image. This is the total process I have explained in a single chart what we have discussed. You can pause it, you can study it, and you can see here the electron which are closer to nucleus has more energy. Those who are in outer circle has less energy. Here we have seen them. And if the impact nucleus hits if the impaction occurs with the nucleus, then will be maximum energy liberation. So it will, analytic study will give you a detail of different type of radiations, how the X-rays are produced, then what is the characteristic radiation, from where it comes. All details we have explained in this chart, in this figure. Whatever we discussed theoretically before, now in visuals I am showing you same things. Now what is characteristic radiation? Here I am showing you with the help of chart. The generation of characteristic X-ray in a target atom occurs in the following sequence. The incident electron interacts with K-shell electron via a repulsive electrical force. The K-shell electron is removed only if the energy of the incident electron is greater than K-shell binding energy. Very obvious, na? Unless it has got more the energy to displace, it cannot displace the nucleus. Then there are shells. The one who is near the nucleus will have a higher energy level, like K will have more, L will have less, and M will have less. So in that way it will occur. Then an electron from the adjacent L shell, now we had displaced from the K shell. Now what will happen if the K shell is empty? What will happen if the K shell is empty? Electron from L shell. Now the electron from the adjacent L shell, or possibly of the different shell, fills the vacancy because the nucleus will pull it. That will result in a characteristic X-ray photon and liberation of that energy, or conversion of the energy into the characteristic radiation. In this case, a 59.3 kVp photon is emitted. Now there is a calculation, there is a chart is available. I will show you. You can pause it and get a more detailed information. Now this is X-ray tube, in which what we are seeing, first there has to be a production of electrons. From where it occurs? From the filament. Then they need to be accelerated. Now how it occurs is, the negative charge of the filament and positive charge of a anode pulls the electron and accelerate their speed. Now once they hit the target, all of a sudden there is a deceleration, and this will result into liberation of X-rays. That is how the X-rays are produced. Now with this we are coming to the end of this lecture. I hope I have made it very simplified and very easy to understand. It is not at all a complicated topic. In case if you liked it, give us a like, share it to your friends, so that technicians, radiology residents will get benefited. In case you want to see more videos, more lectures, do visit our website. Thank you, goodbye and take care. This is Dr. Anil Joshi logging off till we meet in next video.